Okay, go.
Hi, this is a group assessment for BERG4453 Computer Architecture, where we have designed and coded a project using Raspberry Pi 3. Declaration. We hereby declare that the project work entitled Interactive Obstacle Detection Game submitted by us to UTeM is a record of original work done by our team under the guidance of Dr. Anwar from the Department of FTKEK. This project work is submitted in partial fulfillment of the requirements. Through this assessment, we learn how to build code, design circuits, and integrate them with the Raspberry Pi 3. The result embodied in this work has not been submitted to any other university or institute. These are the team. I am the leader of the group, Morgan Raj. Then we have Danesh, who is assigned to be the hardware specialist in this task. Next is Ziad, the pro in code developing. Finally, Asif, our documentation, presentation, and the testing lead. This is the project introduction. In this project, we have created an interactive game that leverages the power of Raspberry Pi and ultrasonic sensor to detect obstacles in real time. The game provides immediate feedback through LEDs and a buzzer when an obstacle approaches within specific ranges. Let's delve into how the game works. The components we use for the interactive game are one Raspberry Pi 3, an ultrasonic sensor, HCSR04, a red LED, a yellow LED, a buzzer, a breadboard, jumper wires, resistors, power supply for Raspberry Pi. Let's see how the game works. At first, we have connected the ultrasonic sensor to the Raspberry Pi and configured it to measure distance. The setup involves wiring the sensor to the Raspberry Pi GPIO pins and ensuring proper connections for power, trigger, echo, and ground. Second is distance measurement. The ultrasonic sensor emits high frequency sound waves and measures the time it takes for the waves to bounce back after hitting an obstacle. This time measurement allows us to calculate the distance between the sensor and the obstacles using the speed of sound. Third is feedback mechanism. We have integrated two LEDs and a buzzer to provide feedback based on the measured distance. When an obstacle is detected within 10 cm, the red LED blinks and the buzzer emits a short beep, indicating close proximity. If the obstacle is between 10 cm and 30 cm away, the yellow LED blinks, signifying a moderate distance. Beyond 30 cm, no LED blinks, indicating a safe distance. This shows a table summarizing the feedback mechanism, indicating the different lights when different levels of distance are exceeded. Fourth is the gameplay. Players can move objects closer to or farther away from the sensor to trigger different feedback responses. The goal is to navigate through the space while avoiding obstacles and interpreting the feedback signals in real time. This makes the game both engaging and educational, demonstrating practical applications of sensor technology. Next is the schematic diagram where Asif will explain all about it.
Hello guys, my name is Muhammad Asif bin Zulhawi, and here I want to explain about our project is interactive obstacle detection game. As we can see, our circuit consists of Raspberry Pi 3, two resistor 220 ohm, one buzzer, two LED which is consists red LED, green LED, and one ultrasonic distance sensor. As you can see in our schematic diagram, the VCC of the ultrasonic sensor is connected to pin 2, the trigger is connected to pin 23, and the echo is connected to pin 24 of Raspberry Pi. And then the red LED is connected to pin 17. Meanwhile, green LED is connected to pin 27 of Raspberry Pi. After that, the buzzer is connected to pin 22 of Raspberry Pi. Last but not least, all the GND of auto sensor and the negative polarity of all components is connected to pin 6 of Raspberry Pi. So, the interactive obstacle detection game is a project where players navigate a character or object to a course filled with obstacles. The primary goal is to avoid or overcome this obstacle to reach a specific endpoint or achieve a high score. This type of game often combines elements of skill, timing, and strategy, and can be implemented using various technology and platform. So, to start a project, we place an object distance between ultrasonic sensor to an object is 30 cm. If the object is more than 30 cm, the green LED will not turn light on. So all the players have to queue up and only push the object to the nearest 10 cm. If any player push the object less than 10 cm, the red LED will turn light on and the buzzer will turn on and the player will get kicked out. And then this process of game will repeated until only one player will stay, and the last player stay will be winners in this game. So in this game and this project, we understand this game design principle and mechanical, and we also learn to develop skill in programming and software developing. And lastly, we can gain experience in problem solving and debugging and creativity and storytelling through the interactive media.
Next is coding. They show how the Raspberry Pi is programmed. The Raspberry Pi is programmed with our project-specific code using the Tony app. Tony is an integrated development environment IDE for Python, which makes it easy to write and debug the code necessary for our project. The code handles distance measurement, controls the LEDs and buzzer, and provides the feedback required for the game. Let's see how the code works. A video is in the queue where the coder Ziad will explain about it and its functions.
Hello, my name is Ziad bin Zamri. Now I will explain about our coding that creating an interactive game using a Raspberry Pi. We will use an ultrasonic sensor, red and green LED, and a buzzer to respond to distance measurement. So for inputs and setup, we import rpio.gpio to control the GPIO pins of the Raspberry Pi and time for handling delays. This one is for disable warnings that might come up if GPIO pins are used. This one is set the pin numbering to BCN mode, which means we will refer to the pins by their broadcast chip specific numbers. For pin configuration, we assign GPIO pins numbers to the trigger and echo of the ultrasonic sensor, the red and green LED, and the buzzer. For set direction, we configure the pin as input or output. For GPIO trigger is an output pin because we send a signal from it. For GPIO echo is an input pin because we read the signal coming back. For red, green and buzzer are output pins because we control this component by sending signals to them. For distance measurement function, we send a short 10 microsecond pulse to start the measurement. So for measure time, we record the time at the start and end of the echo. For calculate distance, the time difference between start time and stop time is used to calculate the distance. So for this one is give the duration of the echo. For this one is convert this time into distance in centimeters, dividing by 2 because the pulse travel to the object and back. For the main loop, the script runs continuously in a while-through loop. For control LED and buzzer, if distance is less than 10 cm, the red LED and buzzer will turn on. If distance is less than 30 cm, the green LED will turn on. If distance is equal or more than 30 cm, both LED and the buzzer will turn off. So for the graceful exit, the try block allows the loop to run until interrupt. This one is to catch a control C from the user to stop the script. Finally, GPIO cleanup ensure all GPIO pins are reset to their default state to prevent issue with the virtual script. So that's all.
This is the result. This is the prototype in its schematic version. Here we can see the components used for the gameplay. This is during calibration and testing. The yellow LED blinks indicating a safe distance between 30 cm and 10 cm. This shows when an object is moved further than 30 cm, indicating safety. This shows the measured distance using the ultrasonic sensor as the box is moved every second. When the sensor detects an object within 10 cm, the red LED blinks and the buzzer sounds. Now we are going to show the gameplay. This is round 1. And the player in the black shirt is eliminated for entering the under 10 cm zone. This is round 2. The player in the orange shirt is eliminated for exceeding the limit. This is the product view. This shows the measured distance. This is the box is moved to the sensor. This is the system which help identifies and triggers the LED and buzzer when the limit is exceeded or the distance is under 10 cm. These are the overall view of the gameplay. Next is conclusion. Finally, here we are in conclusion. By combining these hardware components with our programming logic, we have created an engaging and educational game that demonstrates the practical applications of sensor technology in a fun and interactive way. This project not only showcases the versatility of the Raspberry Pi but also highlights how simple components can be used to create a complex interactive system. Next, this FAQ section will be discussed by Mr. Danis.
So, for the first question is, can the game be modified to include more distance thresholds or different behaviors? The answer is yes, the game can be easily modified to include more distance thresholds or different behaviors. We can add more LEDs, buzzers, or other components and update the code to handle the additional distance ranges or the actions accordingly. The second question is, what challenges did you face while building this project and how did you overcome them? So the challenges was ensuring the accurate distance reading from the ultrasonic sensor. We overcome this by carefully calibrating the sensors and ensuring it was positioned correctly. Another challenge was managing the power requirements and the connections for the LED and buzzer, which we addressed by using appropriate resistors and double-checking our wiring. For question number 3, is it possible to make this game portable or battery powered? The answer is yes. It is possible to make the game portable or battery powered by using a suitable power bank or battery pack to power the Raspberry Pi and the connected components. This would allow the game to be played in different locations without relying on the stationary power source. Question number 4. What are some potential extensions or improvements that you could add to this project? The potential extensions or improvements could include adding a display to show the exact distance in real time, incorporating more sensors for a multiplayer version, adding sound effects or a scoring system, and creating a more enclosure for the components to enhance the game's appearance and durability. For the last question, how do you handle potential inaccuracies and inconsistencies in distance measurement from the ultrasonic sensor, especially in a game setting where precise distance detection is crucial. So, the answer is handling inaccuracies and inconsistent in distance measurements from an ultrasonic sensor involves several strategies. First is the calibration. Regularly calibrate the sensor by comparing its measurements against the known distances. Adjust the codes to account for any systematic deviations observed during the calibration. Second, filtering noise. Implement filtering techniques such as averaging multiple readings to reduce the impacts of the noise. For example, take multiple distance measurements over a short period and use the average value to determine the actual distance. This helps smooth out any irritating readings.
Thank you for listening. That's all from us.